Good morning, everyone. Today we are going to be looking at precipitation and cloud formation. The questions we're going to explore are: how does precipitation form? What are the differences in rain, sleet, snow, and hail? What is an air mass, and how are the different air masses classified? Why does Oklahoma get so many tornadoes? And what are the 4 types of fronts and the weather that goes with each? So how does precipitation form? Well, it depends on if it's a warm cloud or a cold cloud. They're going to start out the same, but when you get to step 2, it's going to split, and then by step 4, we'll come back together. So we start out at step 1, and the saturated air begins to rise very quickly, and that causes it to cool. This produces condensation, and that makes the droplets of water that are in the clouds. For warm air, we have the coalescence process. The condensation starts to collect, which causes the droplets to grow to between 2 thousandths and 4 thousandths inches in diameter. So that's 0.002 and 0.004 inches. Very tiny. So then after that, you come to step 3, and that's where the droplets continue to collide and bump into each other, and they're carried higher into the rising cloud. Here they can reach between 0.04 and 0.1 to 0.25 inches. So 0.04 to 0.1 at its smallest, which is bigger than what it started out at, to 0.25, which is pretty significantly higher than 0.04. For cool clouds, we have the aggregation process. And you need ice crystals and supercooled water for this to happen and take place. So for step 2 in the aggregation process, the ice crystals form very quickly, and as they do, the supercooled water begins to freeze to it. Step 3 is when the ice crystals move through the cloud and they continuously freeze to more and more ice crystals because of the supercooled water, and so it just continues to build up. Like I said, by step 4, we come back together, so no matter whether you're a warm cloud or a cold cloud, the 4th step is going to be the raindrops or ice crystals continue to grow, and eventually they become too heavy for the updraft of air. This means that they're going to become, or they're going to start to fall, and go down because the updraft can't carry them. After that happens, as they drop, the raindrops and the ice crystals fall, and they break into even smaller droplets. So now that we know how precipitation forms, let's look at what the different types of precipitation are. First, let's look at rain. So we're going to go backwards. Sorry about that. I hit the wrong button. Okay, so first let's talk about rain. Rain is made up of drops of water, and they're at least 0.5 millimeters in diameter. They come from mainly nimbostratus and cumulonimbus clouds, although the cumulonimbus clouds can sometimes produce what's called cloudbursts, and they cause heavy rainfalls. So these cloudbursts come and dump a bunch of rain, and then it's over. At the other end of it, you can have the drizzle, and that is usually smaller than the 0.5 millimeters that raindrops are that we talk about up here. And they are produced in the stratus this is produced in the stratus and nimbostratus clouds. Next we have snow, and snow is made out of ice crystals. So we have very cold temperatures that make these six-sided ice crystals, and they collect and make powdery snow. So this is when you have super cold temperatures. This is like the snow that you see skiers skiing on, or you hear them talking about, like the powdery snow. That is this kind. It has a low moisture content. So when you have temps that are higher than 23 degrees Fahrenheit, it can still snow because it's below freezing, but they make larger clumps of crystals, and these crystals are tangled together. This snow also has a higher moisture content than the snow that you get when it's extremely cold outside. Next is sleet, and these are small particles of clear or translucent ice, and you must have a layer of ice with temps above freezing lying on a sub-freezing layer that's close to the ground. So that is what sleet is. Now, a lot of people will talk about glaze as sleet, but they're actually two different things. Glaze is freezing rain, and that is rain that falls and freezes when it sticks. But it's not the same as sleet. Then we have hail. And if you live in Oklahoma, you're pretty familiar with hail because we get a lot of hailstorms with our tornadoes and sometimes even our big just thunderstorms. So hail is made up of hard round pellets or balls of ice, usually between 1 centimeter and 5 centimeters, and they are produced in the cumulonimbus clouds, just like rain. And these hail balls grow by falling through the cloud and collecting supercooled water. So kind of like we talked about on this page with the cold clouds here. So those are your 4 forms of precipitation. Now let's talk about air masses. What are air masses? The different kinds, and what are they made of? So an air mass is a huge body of water, or air, sorry, and that air is typically 1,600 kilometers or more across and several kilometers wide. So that's a very big area to cover. The air moves out of this region that it came from. So like with the CP, continental polar area, this is an air mass, and during the summer, it can come down this way. And that is what this is talking about. It ends up affecting this area by bringing that cold air and mixing with the fronts or air masses that are down here. Excuse me. And creating fronts. So as it moves, it's changed by the direction it goes. So it either cools down or warms up depending on where it goes. So if you have the maritime polar moving down, it's going to warm from the warm air down south. Due to the amount of time it takes to go through an area, the weather may stay the way it is with the front and mass for days. And that is called air mass weather. So with winter, the continental polar moves around the CA and engulfs it, which is the continental Arctic, and they both have cold, dry weather. And then this continental tropic, which is down here, is hot and dry, and it goes away in the winter. During the summer, this will look a little different because the continental Arctic is not there. So these are our different masses, and you can see the different categories. So you have the very dry and cold, which is continental Arctic. Then you have the continental polar, which is cold and dry, but not as cold as the Arctic. Then you have the maritime polars, which are cold and moist. And then down south, you have the maritime tropics and the continental tropics. And the continental tropics is hot and dry, while the maritime tropics are warm and moist. So with these tropics, when they move, they can cause tornadoes. And these tornadoes are caused by these maritime polar masses moving down and meeting the continental polar and the maritime tropics. These all come down and they can create storms when they go up against each other because of the fronts. So in Oklahoma, we get a lot of tornadoes, and this is because we are right in the area where this continental polar and continental Arctic comes down and meets this maritime tropic. And these air masses intertangle and a front moves in, and that is how we get the tornadoes. So what are the 4 types of fronts? We have cold fronts, warm fronts, stationary fronts, and occluded fronts. Cold fronts are made when the cold air actively moves into the place that's occupied by warmer air. This front steepens as it moves from the position on the air mass, and it can move as fast as 35 to 50 kilometers per hour. With this comes rain and wind that is usually very strong, and the precipitation is greater by duration but slower in movement, and it also accompanies a temperature drop and a wind shift. Next, we have warm fronts, and the warm front takes the territory that was once covered by cooler air, and the warm air is less dense, so it's harder to move than cool air. The first sign of a warm front is the cirrus clouds, and about 300 kilometers in front is the rain or snow. Light to moderate precipitation comes from the low slope of the front and the slow rate of advance that it has. It can produce storms, causes a gradual increase in temperature, and during summer can bring heavy precipitation from the warm, unstable air mass, having cumulonimbus and cumulus clouds. These advance at 25 to 35 kilometers per hour. Next, we have the stationary front. The flow on both sides is neither going towards the cold or the warm mass, but it's parallel. It does not move on the surface, and it is gentle to moderate precipitation. Lastly, we have the occluded front. This is the active cold front that overtakes a warm front. The cold air moves the warm front up and creates a new one that moves in front of the advancing cold air and the air covering the area where the warm front is moving. Most precipitation is from the warm air from the first front, but it can also produce its own precipitation when the conditions are right. However, these are all just generalizations of the weather that the fronts bring. Thank you for listening. That's all we have for this lesson. Have a great day.